Hello and welcome to the video on angle measures. By the end of this video, you should be able to describe what an angle is, you should be able to name an angle by its parts, and classify an angle by its size. You should also know the definition of an angle bisector. Before we get started with our new material on angles though, let's quickly review what a line and line segment are. A line segment and a line were very similar to each other. The only real difference was that a line segment ended. If you remember how to name a line segment, we named it with both letters. In this case, line segment AB, or I could have called this BA. Our line we named very much the same way. This was line CD, or I could call it line DC. A ray is going to be named very similarly to a line because a ray is really a hybrid between the two. It's going to act a lot like a line segment, meaning it'll have an endpoint, but the other side will keep on going like a line would. A ray, however, you cannot name any way you want to. A ray has to be named with its endpoint first. This is ray EF. I cannot call this ray FE. Notice when I wrote ray EF, I put the ray symbol above. If I had another point on this ray, let's say I had another point called G, I could now call this ray EF, or I could call it EG as well. Again, notice both times though I started with the endpoint, point E. Now that we know what a ray is, we'll be able to talk about an angle. And that's really our main topic here for today. An angle is really created by two rays with a common endpoint. In this particular example, I have two rays, ray YX and ray YZ. They have a common endpoint at Y. That common endpoint is called a vertex. The two rays are called the sides of this angle. So ray YX and ray YZ are sides. When I want to name an angle, there are a few methods to do that. The most common way, and the way that will work every single time, is to use three letters going around the angle. I can call this angle XYZ. Notice when I name that though, I started on one side and the letter in the middle here was my vertex. It was point Y. There is a second way to name an angle. If it's a very simple picture and there's really no other choices, I can get away with calling this angle angle Y. The reason I can do that is because there's nothing else to confuse it with. That method, however, does not always work. For example, on a more complicated picture, if I wanted to talk about any of these angles, say I wanted to talk about that angle right there, it would be angle YTZ. I could, however, not call this angle T, because if I said angle T, you would be confused as to which angle I was really talking about. Every single angle here is angle T. So you have to use the three-letter method. The third way to name an angle is to use a number. You will commonly see on very complicated pictures that they put numbers in each of the angles, and then that can refer to angle YTZ here also as angle 4. One other thing here, going back to rays, the two rays I had here, rays YZ and YX, made an angle. It is possible to have two rays not make an angle. If I have two rays that don't make an angle, they would be going in opposite directions, and these would be called opposite rays. For example, rays BA and ray BC. These are opposite rays. In reality, those opposite rays really just make a line. There are a few ways to classify an angle. You've probably heard these before, but let's quickly review them. When you classify an angle, you're just going to name it by how big it is. There's really just three choices. The first is an angle that has a measure that is less than 90 degrees. If something has a measure that is less than 90 degrees, that is called an acute angle. The second is called a right angle. That is an angle that has a measure that is exactly equal to 90 degrees. And the last one is an obtuse angle. An obtuse angle is an angle that is more than 90 degrees, but less than 180. We're also going to define what an angle bisector is. An angle bisector is a ray that cuts an angle into two equal parts. If I would have a ray here that would split this angle in half, for example, ray BD, if I told you that ray BD is an angle bisector, you would know that these two angles here are the same size. Notice the notation I've used here. I put the same number of arcs in both of those angles. By doing that, I'm automatically telling you that those two angles are congruent. Let's try a few example problems. The first example, name all the angles that have G as a vertex. There's 5 angles here that are fairly obvious that have a G as a vertex. The first, angle AGB right here, I can call angle AGB or angle 1. For simplicity, I'm just going to call it angle 1. There's 4 other angles going around that are just as obvious. They are angles 2, 3, 4, and this unnumbered angle over here. Since it doesn't have a number, we'll have to use the 3-letter method and call it angle AGF. There is, however, other angles that have a vertex of G. These angles are basically putting 2 of the smaller angles here together. An example of this would be angle AGC. Angle AGC has a vertex of G. There's a few others here as well. Angle BGH and angle CGF. There's probably a few others as well, but that's all I see at the moment. Let's move on to part B. Name the sides of angle 2. Angle 2, highlighted in red here, is otherwise known as angle BGC. It has a vertex of G, and its sides would be the rays that make that angle. They are ray GB and ray GC. Part C. Write another name for angle 6. First thing we should do is find angle 6. Because we've named angle 6 using the number, the only other choice we really have here is the 3-letter method. You can't get away with using just the vertex because angle F here could be referring to both angle 6 or angle 7. I need to call angle 6 angle GFH. And part D, name the point on the interior of angle GFC. When they refer to the interior of an angle, they're talking about something on the inside. This is opposed to the exterior. So let's find angle FGC. FGC is referring to that angle right there. So on the inside of that angle, I have 2 choices. Those 2 choices would be point H or point D. Let's try another example. Problem number 2. Use algebra to find the angle measure for each figure. Let's start by drawing the picture. We were told that these 2 angles are congruent to each other, so now that we have both angles, them being congruent means they have the same measure. I want to put the same number of arcs in here to show that they are congruent. I'm also going to put the measure of those angles right inside. Now that I have my angles, them being congruent means they have the same measure. So if they have the same measure, I can set them equal to each other. If they're equal to each other, I just have an algebra equation now to solve. So I'll solve an algebra equation by subtracting my 2x from both sides. Then I'm going to add 10 to solve for x. Now that I have that x is 15, I can find the measure of both of these angles by plugging the value back in. I'm really looking for the measure of both of those angles. I know the measure of angle GBH was 2x plus 5. So if x is 15, 2 15s plus 5 would wind up being 35 degrees. Now we know the measure of angle HCI should be the same thing because the problem said they were congruent. Just to verify, I'm going to plug x back into that angle as well. I have 3x minus 10. Since x is 15, I'm going to plug in 3 15s minus 10 to get 45 minus 10, or 35 degrees again. This means both of our angles did indeed turn out to be congruent. We know we got our problem right. Let's move on to problem B. Again, to make this easier for us, I'm going to sketch out another picture. Now that I've sketched my picture out, I'm going to take a look at what they gave us. We were told that angle EBC is being bisected by a ray called BD. If it's being bisected, we learned earlier that means it's being cut in half, which means both of our smaller angles here are congruent to each other. Now I'm going to mark what I know on the picture. The measure of angle EBC is 8x plus 32, and if we look, EBC is our large angle here. We also know the measure of angle DBC is 6x plus 4. And the measure of angle DBC is just one of our smaller 2 angles. Since we know they're congruent, I also know that the other angle is another 6x plus 4. So I can solve this problem by saying that both of these small angles together add up to be the bigger angle. So in other words, 6x plus 4 plus 6x plus 4, or 2 6x plus 4s, has to equal the 8x plus 32. At this point, it's just another algebra equation. We're going to distribute. Now that we've distributed, we have 12x plus 8 equals 8x plus 32. I need to combine together my x's. I can do that by subtracting 8x. Once I subtract the 8x from both sides, I'm going to wind up with 4x plus 8 equals 32. Now that I have that, I can solve for x by subtracting my 8. When I subtract 8, I wind up getting 4x equals 24, and then divide by 4 on both sides. This gets me x is 6. Now, like the previous problem, I'm not really just looking for x. The problem says to find the measure of angle EBC. This means I'm going to have to plug x back into that angle. The measure of angle EBC is 8x plus 32. Since x is 6, I'm going to plug in 8 times 6 plus 32. This gets me 48 plus 32, or 80 degrees. This means the measure of angle EBC is equal to 80 degrees.